All right. Yeah. Thank you for that introduction, Jonathan, and thank you for the invitation and for also coming here to again getting a chance to present at CJUG. At least one thing to what Jonathan said. I also help run the Java user group in Kansas City, and definitely that's like one of the best ways you can help with, just as being a member of a user group is by bringing someone else with you, because that's always great when it takes a lot of effort to kind of organize these events, and then getting a bunch of people to come out is great. And thank you everyone for coming out to listen to me speak, and I hope I live up to expectations and you learn something really interesting. So this presentation, Java to the Future, we're going to be looking at the future of Java. With that said, some really, so I've been switching over, I've been using PowerPoint during, and of course, we kind of ended up being an issue with this as well. There you go, that at least helped a little bit. Where I switched to use from PowerPoint to using Reveal to make it a little bit more bigger text, because I was realizing going from pandemic to in-person, I'm like, oh, like we can run my slide or view my slides, the text was so great. Still working out some kinks on that. But all the same, you can find this slide, the slide deck at this link, so you can check that out for sure, and I'll be sure to share that link with the organizers also. But definitely, please ask questions. So luckily, one of the really nice things about a user group meeting is we have a very flexible endpoint. So, you can have a conversation. If at any point you want me to go into more depth, definitely feel free to ask. A couple of these areas, I'm not as super familiar with. So, I may not always go as much depth as possible, but definitely some other areas I know much better. But you also, if you leave with an intense desire to know more, we have some great information at these sites. So dev.java, that is a site that my team at Oracle, or the team I'm on at Oracle, runs. We launched it back last September and has great tutorials, reference information, and also even ways to find community information, like finding jugs in your area. Obviously, already found CJUG, but there's also things like conferences, and maybe there is also another jug nearby you want to check out. Particularly relevant for this presentation would be Inside Java, and that is kind of like where we post information for like the developers of OpenJDK itself. So if you want to kind of figure out about like what's coming in Amber or new tools or all the other like project Loom, Valhalla, and all that, Inside Java would definitely be a really great source. We also run a YouTube channel where you can see our Inside Java podcast, our newscast. You also get the podcast, and all your sources as well are all the Spotify, Apple Podcasts, all that. And as mentioned, we also have, or I do, the 1 minute Stupid Java episodes every Monday. That's also posted over to YouTube as well. So before I get into this presentation, though, I definitely want to kind of give a bit of a warning that a lot of this presentation is going to be covering stuff that's going to be coming in the future. And as Dr. Brown said, the future isn't written, it can be changed. So what this means is timeline can change, priorities can change, and really importantly, implementation details can change. Certainly some of these things we'll be talking about have in fact changed over like the past year or so. So, you'll get definitely a good idea of maybe kind of like where we're trying to go and what we're trying to do. But some little things here and there might change, so don't necessarily go back to here, a year or two from now and be like, wait a second, this code, so doesn't work now. Well, again, implementation details might change a little bit. But that said, let's actually start getting into the primary content of this presentation. And first, we're going to talk about Project Amber. If you're not familiar, Project Amber, the goal of Project Amber is to introduce small productivity-oriented Java language features. Oops, I need to correct the typo there. It says it beats. But this is where a lot of those new language changes that you've been hearing about over the recent releases have been coming from. The key changes I'm going to talk about here are going to be the update to switch, pattern matching for instance of records and field classes, because they're kind of building upon stuff that's going to be going into the future as well. But then also like var and text blocks are also delivered under Project Amber as well. So first I want to talk about is Swift updates. These were added in Java 14, and the JEP for them is JEP 361. Did I close that? Let's see. And so if you're not familiar with what JEP means, JEP stands for JDK Enhancement Proposal. And so whenever there's a somewhat meaningful change to the JDK, it goes through the JEP process. And so I think that was 361. Fortunately, a little wonky. So 361. Yeah, so I put the JEP number up there for a lot of these changes that we'll be talking about, past and future. And this can give you a lot more detailed information about something that maybe you're specifically interested about than I have time to go into today, because we're going to be going through a whole lot. And of course, I can only maybe spend, 5 or so minutes. So definitely refer to this. And then there's also, jumping off points from here as well to get into more detailed information. So switch updates though. So we're all familiar with the colon syntax for switches, and they're pretty verbose. There's a lot of structure to them. We, particularly in the break statement that ends every case, and kind of then within that, it becomes a little bit more cumbersome to read because you have a lot of structure around it. And then it also really, creates opportunities for introducing bugs, who amongst us has forgotten to put a break statement within a case, if that's a production, and then all of a sudden you find you have a bug in production because you kind of forgot about fall through by default, or you were just maybe doing some testing and you just accidentally remove the break statement without realizing. So updates remain to switch. Colon syntax is still entirely valid. You don't have to change anything. But now we have this new arrow syntax. And with the arrow syntax, if it matches on a case, only the code to the right will be executed. Now, if you did need to actually have some sort of more complex behavior to be handled than it can be done in a single statement, you can put blocks of curly braces to actually execute a block as well. You can also with switch now write it as an expression where you yield a value out of it. With an expression, since I already write it as an expression, you can also again write it as a block. You would just need to end that with a yield, which will then return or yield that value out of that switch expression. When you're writing it as an expression, it does have to be exhaustive. So most of the time, that means that you're going to have a default statement within there as well. And of course, when you're doing an expression, all the values have to be matching to whatever you're returning it from. Also, you can do the colon syntax as an expression as well, where you just would put a yield for each, or a yield statement in each case as well. And of course, it would also still have to be exhaustive. Next, we're going to be talking about pattern matching for instance of. This was added in Java 16, and particularly within Project Amber, pattern matching is going to become an important theme. Indeed, the name Project Amber, so initially when I heard like all the other projects like Loom, okay, that has to do with threads, Loom, fabric, Loom to make, material, and Panama, native interface, connecting OSIN, so that makes sense. But where Project Amber comes from is actually a 1980s book called The Chronicles of Amber, where within the book series, there's like a rite of passage called Walking the Pattern. So that's where the pattern actually comes from, and that's how it got its name. I'm like, wow, that is super nerdy even for me, because I was kind of thinking it was like a tongue-in-cheek reference to Java being stuck in amber, kind of like from Jurassic Park, where you have like the mosquito that's stuck in amber. So anyways, I thought that was kind of funny when I actually learned the real history behind it. All the same, pattern matching for instance of. So again, we've all, maybe a couple times, instance of isn't necessarily the most common thing we were working with unless you're in specific areas. But like, whenever you maybe have some sort of reference type where you don't know its definite type for whatever reason, and sometimes you have to do instance of. And again, it's a bit verbose and wonky to work with, where here, maybe this object is supposed to be some number type, and it could be an integer, long, double, or any other number types. And you have to do like, okay, I'm going to check if it's an integer. If it's integer, okay, then I create my variable. you have to still pass it again to use it. And again, just as kind of some opportunity perhaps to where doing a whole bunch of these together to actually include error where you maybe don't properly cast or something like that. So now this is pattern matching where you can do a check and then it will immediately assign it to a variable, in this case I, and this is flow scope. And if you're not familiar with flow scope, this is pretty new to Java, is I is in scope wherever the compiler definitely knows I has actually been set. So effectively wherever the predicate is true. So that means I would be in scope for here for within this subsequent block for the if statement, but then it wouldn't be in scope outside of it. We can see some of the benefits for that in a moment. But as we see other areas for pattern matching, again, as a predicate, in this case, is going to be is some number, an instance of integer. And again, if that predicate is true, then it will assign it to this pattern, variable I. So we'll see, again, a few other areas how this is going to be pretty beneficial. But here we can see the benefits of how I being flow scope. So here I'm doing several different checks on it being an integer. And here's like, okay, for this first one, integer I, if it's greater than 100, then it's like a large number. If it's greater than 0, then it's a small number. We're positive. If it's less than 0, it's a negative number. But I can still use I in all these examples. I don't have to kind of come up with like a different arbitrary variable type for each different statement or each different if comparison. So that's kind of nice as well. And it kind of works as expected with how flow scoping works. What was it, sorry? It will. We'll actually get to that in just a moment. Pattern matching is coming from switch. So the next is I'm going to talk on records. That was added in Java 16, and the JEP for that is 395. The initial benefit, or the one that maybe developers are initially recognize with records, is its reduction in verbosity. I know this is a whole lot of code that you can't really see all on screen, but like imagine maybe I'm doing some sort of like ETL work, and I have like some number of like fields coming in that I need to like put into some sort of like little wrapper class. And if I wanted to define that within a method, all the meaning of that method would just be kind of lost just because of how much it takes to define even a simple data class like this simple person class in code properly. Once you include equals and passcode and all that, it becomes super verbose. And so all the meaning of this method is completely destroyed. Oh, yeah, sorry, Jeff. Thanks for asking. And actually, the question that was just asked was about with instance pattern matching for instance of does it work for switch? Yeah, thanks for mentioning that, and I'll be sure to try to remember to repeat that in the future. So anyway, now with records, you can define all that previously I was taking dozens of lines in a single line. Now, if I told you that the point of records was just to reduce verbosity, I would get a very angry email, something from like Brian Getz, who's the lead architect of Java, because that's not the primary point of records. The primary point of records is to be able to transparently model data as data. And so, and what that kind of means is when I define a record, as I do here from the previous example, you can immediately, just from the definition of it, really kind of know all you need to know about that record. You, of course, will know its name, and you will know that it's, has 4 fields, first name, last name, title, Twitter handle, and all of that. And the way you know that is because of the constraints that are put upon record. A record, its superclass is always going to be record. So as a result, it can't be extended, it can't be abstracted, as a result, implicitly final. So it's not going to be bringing in behavior for some sort of superclass that you're going to have to then kind of look through the hierarchy to kind of make you understand it. You can't define any additional instance fields. The fields are final, but they're of course shallly immutable. So if you have an array and there are an array list, you could, modify that array, but you can't change the reference. In general, you would want to avoid using arrays within records because of their mutability, and then also the difficulty around how you would be doing equals with them. So definitely, if you're using records, make sure to use a list, and particularly an unmodifiable list or an unmodifiable collection to kind of really be consistent with the purpose of a record. But then with these constraints come the benefits of being able to define in a single line where the compiler will then automatically generate accessors as code toString equals automatically generated. But of course, you can override these default implementations or add your own definitions as well. So accessors, to also keep in mind, it doesn't, so like we're all familiar with like getters and setters, and that's part of the Java Bean standard. That's like a standard that's outside of Java. The accessors would just be using the name of the component. So if I wanted to reference first name of the person record, then I'll just do, like the instance dot first name to retrieve it, not get first name. Yes, absolutely. And that's in the definition of the record or the fields of the record? The fields of the record. So the question is, why was the decision made with records to require all the fields to be final? So I think it's just to kind of have a concept of immutability with records, to kind of have them not change once they're set. As for the why, so yeah. Yeah. Uh-huh. Yeah, yeah. And just to relay the comments to the watcher, so he's comparing to Kotlin, how in Kotlin you can have some choice in whether or not it's a immutable data type versus a mutable data type. It's one of those where Brian Getz kind of put together an article, like a white paper, like a couple of years back, where he kind of goes through like all the different concerns when it comes to defining a data type. One's like providing mutability versus immutability and those things. And that might be kind of good to kind of go through and look through that, just because as to the internal reason from the architect as to why it was chosen. Like, I think he kind of covers it there as kind of why they chose to go through immutability. And I think also the JEP provides a bit of justification. Can't quite remember offhand the specific reasoning as to why they went with immutability, other than just to kind of, maybe be consistent within the concept of a record. There were typically a record is once it's set, you can't be changed to the concept. Sorry? Okay. Okay. Yeah. And the comment from the audience was that it was to extend the concept from Orlando where of immutability. So yeah, it's one of those. It's always difficult just because there's no definitive one right answer, and so that sometimes you have to kind of choose a specific implementation. And maybe at some future point there will also be like a mutable kind of form of like a record, not of a record, but some similar thing. Yes, question? Uh-huh. So one particular, okay, so the question is, comparison to Lombok. In Lombok, you can, like, I'm just relaying for the here. Lombok, you can set like a final field. And so what would be the benefit of using a record over a Lombok beyond like the syntax? So one specific benefit of using a record over a Lombok is because it's actually built into the language itself. It addresses like some serious security concerns around serialization. So serialization is kind of like one of the original mortal sins of Java. And that largely kind of comes from the fact that there's a bunch of magic methods when doing serialization that kind of go around the constructor of it. And in Lombok, because it's built kind of on top of existing Java infrastructure, it can't really benefit from that. But with a record, you have to actually reconstruct a record through its canonical constructor to build it, which again addresses a lot of the major issues, not entirely quite all of them serialization, but a lot of them. So that's definitely one major benefit of that. Any other questions about records? Or? A copy, not yet. I do know, so the question was, is there going to be copies for records? There isn't yet. I do know Brian Getz, he just posted about how we're going to work on adding withers to it, which I'll kind of mention here at the very end. And I think maybe also mention copy within that as well. Certainly the story on records isn't done yet, which will include also pattern matching later on. Yes. Yeah. Oh, thank you. Um, Great. Yeah. The comment was is that it was nice that Scala has had the concept of records, immutable records for some time, and it's nice to be able to do that now in Java as well. So yeah. Yeah. And that actually gets to something that also Brian Getz also talks about when it relates to Java, because certainly, you know, that's something we kind of hear about a lot. It's like, oh, we add pattern matching or we add records. And it's like, oh, well, Scala or Python or something has had that for a number of years. And, you know, I mean, maybe it's also a little bit saying that because it's the way it is, but what Brian also kind of talks about is what's called like the last mover advantage, in which we kind of look and see how did Scala or how did Kotlin or how did these other languages, you know, even outside of the JVM ecosystem, actually implement these kind of concepts. And then, you know, one, are they actually used? And then two, how could we maybe avoid perhaps some of the pain points within that when implementing similar functionality within Java? I don't cover it in this presentation, but to the comment kind of about copy of, I'm going to talk about with withers, is like I know withers, they are in C sharp, but one thing he was talking about, Brian, in this white paper he put out about it was like a constraint on withers within C sharp about, I can't quite get in, try to remember the details offhand, but maybe not to where it was very simple in its implementation, and how some of that could be perhaps extended upon when it's perhaps implemented in Java, to where you could have a bit more of a block of code to be executed within that wither to maybe allow for a little bit more complex behavior. Again, back to the earlier part with the Doc Emmett warning, maybe that it turns out not to be possible, but again, that could be some of that stuff like, oh, okay, these other languages did records or they did withers and stuff, how are they used, and then how they can maybe be improved upon when they're implemented in Java. Yeah, great questions, great comments, and definitely keep them coming. The next one is I want to talk about its sealed classes. These were added in Java 17, and the depth for them is 409. Okay, I don't know why that didn't come up. That was working just a little bit ago. But, well, what the picture is supposed to show there is a very simple class diagram. But what sealed classes are allowing you to do is allow a class to define who can extend off of it. And where I think this is useful for most like application business developers is like every organization, every company, you're going to have like some amount of like domain concepts like transactions, user types, item types. You kind of know maybe from that what I'm kind of talking about. And there may be actually a certain kind of limited, examples or extensions of that concept. Before sealed classes, there was no real way to define that kind of concept in code. You can kind of, explain in Java doc, like all that stuff, but you couldn't really define it in code. Well, now you actually can. And so what this was supposed to show was, again, an example of user class, and a user is saying only admin, customer, and guest can extend up all of it. So you would define this is an optional permit clause. And then the classes that extend off a user, they would then either have to be defined as non-sealed, as a case in customer, maybe customer, there's just a bunch of different types of customer, and so you don't want to create a sealed hierarchy on it. So non-sealed basically means this is a normal class. Or you would have to define as final, like in guest, when of course that means nothing else can extend off a guest. Or it would have to be sealed itself, in this case with admin. And one thing to keep in mind also, permits is optional. So if you use permits, that is to reference external classes to that class file of what can extend off of it. If you were to define classes in that same class file, that would be automatically considered the only classes that can be extended off of it, in which case, not only do you not need a permits clause, but you would actually get a compiler error. So, but yeah, so these are examples of that as well. But yeah, I think it's good. Like I said, when a class extends off of its sealed hierarchy, it has to declare whether it's going to be non-sealed, sealed, or final. But it does allow flexibility where it's not this whole top-down hierarchy where even user can define a subclass kind of what it can do. Like I said, it's a good way of putting into code certain domain concepts. So what are some of the themes, though, out of all this? Well, it's to be a bit more, that's a bit small, it's to be more expressive. It can be more easily defined meaning derived from the code. I think particularly a good example of that so far is in the switch, the update. The switch is much easier to read that than it is with what was possible with the colon syntax. Also safer, so in some ways your areas get more compiler warnings. We'll see a little bit more of that with some of the more other pattern matching coming to switch and some other areas soon enough. Addressing some security issues like I mentioned with records. Also some fear concerns with nulls because pattern matching is naturally null safe. And of course, also reducing verbosity and ceremony, but it's also not just about typing. It's also, again, about reducing opportunities for bugs. Again, kind of going back to switch where, if we're getting to put a break statement in there and then introducing the bug into your code. So to the pattern matching, does it work with switch? Yeah, that is in fact one of the things that is going to be arriving here very soon. As of Java 19, we're in the third preview for switch. And make that a little bit smaller. The big changes in the third preview is some updates to how null cases behavior is handled, and then also adding a when clause, which replaces the guard clause, which I think is just to better delineate between the pattern matching portion and then any sort of check within it. So here we can see, the pattern matching here where it's like if it's of the type triangle, and then where we can then in the when clause do a check on it to see, you know, okay, it's over 100 in area, so that's a large triangle. And then you just have a triangle if for anything under 100, and then a default execution. When you're doing pattern matching, even if it's written as a statement, it does have to be exhaustive then. Why did yeah, so the question is, why was the change of the syntax? Are you talking the change of the syntax from preview 2 to preview 3? That was doing a bunch of if else's. Well, before in pattern matching for Switch, you couldn't, or there was no pattern matching in Switch. So yeah, I think so. Yeah, so this is maybe so. This is why I was doing if else's here, and yeah, pattern matching. So like why was the when clause added? I think again it was to better say to differentiate from the pattern matching to then the actual additional checks to the variable. Yeah, I can't quite remember the specific. Yeah. Yeah. Well, I think. Yeah. Well, I think also then it's because like if you would have like an and then like, okay, it's an area greater than 100, and then maybe you're comparing the sides of pi if it's like a right angle or something like that, you do like another and, you know, another double and on it as well. And I think you can maybe look a bit weird, or if you want to do like an R around it. Well, I think yeah, no, I understand that, but I'm saying that's to make it more clear though, that separate the pattern part from it from the rest of the comparisons of it. So just to make sure relating what's going to discussion is again kind of the discussion around why was the when clause defined within it. No, go away. So yeah. Record patterns also. So record patterns, it's basically kind of creating what almost looks like you're referencing a constructor, as you can see here. And then it does matching based on the position within what your record is defined with to then extract those values out of that record. So it just makes it that much easier to pull values out of it. Like it's doing by matching by position. So you can also replace this with like var as well if you wanted to, if you didn't want to care too much about the specific variable type. And it doesn't have to match on the name of the class. So like if point was A and B, it doesn't matter, X and Y would be perfectly valid within this pattern matching. Going forward, like I said, there's supposed to be withers coming at some point. That was just kind of discussed. So that's probably going to be somewhat farther down the line. Also string templates, that's going to be really nice. I've actually was working on a little side project where having string templates would have been very helpful. More concise method bodies, and also like the pattern matching. Sorry, just getting started. Yeah. It would get a compiler error. So the question was, is that are these actually then matching on the declared types? And yes, they would have to actually match the type. So if this is long or string or something at this point, and it tried to do that in pattern matching on it, it would either be a compiler error or certainly in that runtime exception, probably compile error whenever you compile within that if you mismatch the types on it. All right. For next steps from further learning, just on the slide, have a link to the Project Amber OpenJDK project, the dev mailing list. And then one of my colleagues, Nikolai Parlog, actually I'll be consistently linked to these videos. He has a great series of videos where he talks to the various OpenJDK project leads on the various states of their project. Some of these are about a year or so old, some are a few months old. So obviously, there's a little temporalness to them as well. So where, if it's obviously a year old, they'll be talking about things in the future that have maybe already happened or maybe slightly changed. The next project I want to talk about is Project Panama. And Project Panama is about connecting the JVM with native code. Now, this might be an area where a lot of Java developers don't have a lot of particular interest in. I know in my experience, I've never really interacted with the Java native interface, which is what Project Panama is improving upon, just because I've been mostly a web developer in my career, so I've never really needed to kind of interact with those areas. But the big changes are currently on the way. The first is a vector API, and that's the API that can better do vector computation, which again, if you're doing like image processing and areas that heavily work on vectoring, can make a significant improvement. Currently, this is in its fourth incubator. If you're not familiar, so there's both preview status, so that's something that's actually within the main JDK that's getting near complete, but we're kind of opening for feedback. Incubator, it's actually its own separate module, and that just kind of really indicates the API is currently in much a larger state of flux. We want that they're available so people can actually have an easy opportunity to work with it, but to further indicate that, hey, this API is very much in flux. One of the reasons that it's still in incubator status is a lot of this will probably change with Project Valhalla. So it's not going to really come out of incubator status until some of the stuff that's depends upon in Project Valhalla is actually delivered, because it could so fundamentally change the API for it. So why put it out early just to be like, wow, why did we do that when it could have been so much more improved? Oops. I can fix that real quick. Maybe. There we go. All right, there we go. Sorry about the little bit of graphical issues. Was working on this slide deck just before I got our report here. But yeah, with the vector API, so like assume that like both A and B are the same length of arrays. With like the vector API is like the JIT can kind of detect like, okay, these A and B are the same length, and then vectorize it to where instead of going through this array and just doing each operation individually, it can do all 16 at the same time. If that sounds very high level, it's because, well, I don't really work with the vector API, and this is kind of an area that I'm not as deeply familiar with. The foreign function and memory API, again, this is where if you've been using the JNI a lot, this is an area that's been very brittle before and also quite dangerous. And the foreign function memory API is supposed to be kind of improving upon that by being less brittle, more consistent, and then also less opportunity of failure. It has actually just moved into preview status with JDK 19 424 after being in incubation for, I think, 2 or 3 re-releases. But kind of, with foreign function memory API is concepts are called linkers, where you kind of look to a native library to, in this case, a radix sort. And then you can also allocate memory as well within the native on-heap memory, and then also assign off-heap memory to then, again, use standard libraries or native libraries to take advantage of them for maybe doing things like sorting or other native library things as well. And Panama is not an area as I'm in depth on, but definitely if you're interested in it, you're definitely interested in it. And then again, you can check out the OpenJDK on that, the dev mailing list. Oh, and well, I don't think I need to update the title, but yeah, that actually does link to the Project Panama by Nikolai Pollack. Next, we're in Project Loom. I think this is actually one area that everyone is extremely excited about. And so, of course, Project Loom is about primarily it's about providing lightweight threads. So currently, when you create a thread right now in Java, that is then actually a system thread. And system threads are very limited, they're very heavyweight. And that's particularly problematic because I'm guessing most people here do web development. And of course, whenever you have a request come in, that takes up a thread. Then, there may not be always work happening within it. So that significantly limits your ability to service requests when each request is very heavyweight, even if it doesn't need to be. So the virtual threads, they're lightweight threads. They really only exist in memory. That then a JVM will handle it and create carrier threads that then actually call to the platform threads. And then as like a virtual thread might not be in use, then it will just kind of park it while it will then other virtual threads that might actually be needing behavior or need processing happening, then it'll execute them. And then also it will avoid blocking calls. So like you're making a call to the database or you're making a call to the file system and it's taking time for that process to happen. Again, the JVM will just park it to process other threads that are actively in need without just blocking off a thread the entire time waiting for a response. But the big benefit of this, because we can kind of go ahead and get that right now with reactive design, but reactive design isn't particularly natural to Java developers. And it's also pretty difficult to debug because you're detaching behavior from the actual the actual execution or flow scope of the application. Whereas with virtual threads, it will remain much more consistent and easier to debug because it will all be just all this behavior will be happening in the same thread. But yeah, JDK or Loom has now its first preview with JDK 19 with JEP 425. So definitely check that out. An area we're going to be very interested to have feedback on. The next big area is also structured concurrency. So now with the ability where threads being so cheap, it does make much more sense to, as much as you can, to maybe break up a task into multiple subunits that could then be perhaps executed concurrently. And so structured concurrency makes it easier to do that. So you can retreat these tasks all as a single unit of work and then have improved error handling, reliability, observability, and really comprehensibility to it as well. Structured concurrency is currently in incubation status. So again, yes. What's the difference? So the question was, what's the difference between Java structured concurrency and Kotlin structured concurrency? I can't really say. I never really worked with Kotlin structured concurrency, so I can't really give that comparison. Yeah. Uh-huh. Yeah. Yeah. Um, I haven't personally worked with structured concurrency in Kotlin, so I can't give a good meaningful comparison. So I won't, because it would be given an answer without any necessarily basis in reality. But yeah, so oh shit, no, sorry, like the well, yes, yeah, certainly you're almost certainly right. So the statement was is that Java structured concurrency is being developed with knowledge of Kotlin structured concurrency, and yeah, you're right. And I just can't quite sit here, and I'll get you in this moment, and say what lessons we're taking from it and applying it to structured concurrency in with Loom and in the JK itself, just because I haven't worked with both to really do a comparison. Yes. Exactly. That's a perfect example where, yeah, the updated datetime API in JDK8 took influences from Jota, but it didn't exactly copy it. Yeah, well, yeah, 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 yeah. So the question was, would the JVM be aware if it's running on CPU architecture versus GPU architecture, and then take that into account in how it is handling it? And I don't know. I have not ever heard that mentioned, so I don't think so. And I think that would probably be more to do with Panama than with Loom. But that's a kind of a bit of an educated speculation, because I just have not heard that mentioned by like Ron Presler when he kind of talks about Loom. So um, yeah, I, I thought I put some information here, but yeah, the primary goal are, I'm pretty sure Ryan gets said it. I just can't quite find where he said it, but like one of the goals of Loom, he kind of somewhat tongue in cheek said, is to really kill reactive programming, at least within the JVM, because fundamentally the reason you do reactive programming is for the horizontal scalability, because again, whenever you spin up a thread, that processing, whatever the task is being handled, it's not always being actively used. So, reactive programming can park that stuff when it's not being in use. But again, reactive programming is very different. It creates very difficult debugging portions, because, it'll be like, oh, this error happened. And then within a stack, it's like, what caused that exception to potentially happen doesn't really relate to the stack trace. Now with Loom, because threads are going to be so lightweight, threads can be parked without being a substantial resource drain on the JVM or the system. And then when exception happens, like the stack trace would be still legible and make sense. Some of the things that will be at least initially difficult with Loom, particularly tooling, is that like right now, if you went into a debugger and looked at Project Loom, like most debuggers would be able to show like, oh yeah, it's like the thread to it looks like any other normal Java thread. Where the difficulty might come is like you can, spin up hundreds of thousands and millions of looms, whereas most debuggers and all the tooling is currently conceiving of hundreds of threads or something, in which case that's something to be reasonably thought of. But all of a sudden you have a million threads, debuggers, if they don't crash, you're going to look at it and be like, what? There's a million threads here, and that'll be difficult to comprehend. So there's going to be some things where tooling is going to need to catch up with some of this new concepts where threads are super cheap and lightweight, kind of like, you may have many thousands of instances of string or whatever. And of course, you're not going to look at each individual string variable or something like that, or instance within your heap. So debuggers are going to probably have to catch up to this new concept that just simply didn't make sense before. And some things also with like garbage collectors and JFR, JPEG flight recorder, are also going to kind of have to catch up to the stuff. Like they can work with it right now, but they just are going to have to kind of catch up to when there's going to be the scale of hundreds of thousands to millions of threads that they just weren't necessarily architected for. To where they do that, there might be some issues. But once again, link to the Project Loom OpenJDK page, the dev mailing list, and then also a great interview between Nikolai and Ron Presler, the head of Project Loom, on the current state of Project Loom. About a year old, but it's all still quite relevant. The last project is going to be Project Valhalla, and its goal is again to introduce some advanced Java VM and new language feature candidates. The main overriding goal, though, is to kind of unify the type system, because like right now we have primitives, we have classes, reference types. No, that's not what I wanted to do. So kind of where issues that kind of come with that is like reference type, they have identity. You create an identity that's extra overhead, there's immutability, there's locking, synchronization, all that, and that's not always needed. A really great example of that would be some of the value-based classes in Java, like integer. If you have an integer class or integer instance that's 100, well, you don't need multiple examples of that, because 100 for the integer is just going to be as relevant to every other one. So things like identity and mutability wouldn't make sense for it. Also, sorry, reference type references, that's going to be for that. So it comes with memory indirection, nullability, and protection from tearing. And again, that's not always needed. You may want to be able to allow tearing if that may not be an issue for your value type or nullability, and all that. So that all comes with potentially significant performance overhead in areas where it is not needed. So the project Valhalla, the goals are to introduce value types, which is about identity, primitive types, which is about identity and references, creating universal generics. So you can have like make that a little bit bigger, to where you can have an array list of int, and then also specialized generics like int-backed arrays. And some things of what can you do now, though, as Valhalla, it's still a little bit off, but as it starts maybe to deliver, well, actually this even goes kind of back to the JDK 8 days, but if you try to do synchronize on value types like long, you'll get a compile error, so definitely look for those. Or if you try to initialize like a value type, again, long is the example, you'll get compile errors, compile warnings for that. Sorry. So definitely look for that as well, and then remove them as needed. But yeah, the next step, again, the Project Valhalla OpenJDK page, the dev mailing list, and the state of Project Valhalla. And again, another great interview with Nikolai, and it's Brian Getz on the current state of Project Valhalla. Yeah. Uh-huh. Yeah. Uh-huh. Yeah. So the question is, does it allow type erasure? Um, yeah. Uh-huh. Yeah. Uh-huh. Yeah. Yeah. I think that it could be done with the, you can create a, I believe that could be done with like creating a primitive type of, and then the field with it would be a string of it. I believe that's how that would be. Uh, yes. Yeah. So Project Valhalla is still somewhat early. Like there's no been even incubation of it yet. So a lot of that, again, to the a lot of it hasn't been defined yet. So I don't know if some of the design constructs will be able to better handle it to where you can get a similar experience in Scala or Kotlin to where there'll be less ceremony around it. Oh, sorry. Thank you for reminding me. So the question was for type eraser that, for example, not all strings are the same. Like one could be a string for a user ID, another could be a string for an order ID. How can you create types to where when you're interacting with like a database to make sure that they wouldn't be compatible? In Scala, it handled very gracefully. But then, at least right now, there's a bit of ceremony in the examples they would have for Valhalla, where you had to create a primitive type of like a type and then put like a string within it. So yeah, I don't. Again, to kind of what I said with the earlier statement, the quote unquote last mover advantage with Java. Certainly, the Java language architects are aware of Scala and how they have implemented some of that behavior. And I'm sure that stuff will be taken into account to, a big goal, Project Amber and others, is to reduce the ceremony. Certainly, as a big goal in other areas within the JDK is to reduce ceremony around it. So that would be a major goal, no doubt, as well, to do a little. But again, there's always for the argument of very little ceremony. There's no doubt also been cases to where perhaps some amount of additional ceremony would have been perhaps beneficial in certain cases with Scala or Kotlin. And so some of that is also always going to have to be kind of weighed within that, just because when you're dealing with a user base of, I think there's 10 million plus active Java developers, there's huge amounts of different edge cases that have to be taken into account. And we want to make sure that all of them are being addressed in at least a reasonable way. Certainly, there's cases where early on, like with the follow through by default on Switch, that was taken from C++, thinking that, oh, that's of course what Java developers would also want to be consistent with C++. But then that is in fact something almost no Java developer actually likes. So, there's always a balancing act. And where there's no always definitive right answer to some of these things. It's just certain opinions and to it. So that's it. We recently did a newscast on, so JDK 19 was just forked off the mainline. So it's kind of really now in the ramp down phase. So there's not going to be anything else added to it. And so Nikolai and I helped edited it, did a video on that, which covers then a lot about Project Loom, Project Amber, and then also or I guess not too much, a little bit in Amber, but then also Project Panama. So you'll be able to get a little bit more depth on some of the stuff I covered in this presentation by checking out that video as well. But yeah, and thank you. And yeah, any more questions? And of course, also for anyone watching, if you have any questions, feel free to speak into my ear, and I'll try to share any questions you have with everyone else and try to get it answered as well. Yes. So yeah, initially the question was the LTS releases. Yeah. So speaking of or mentioning Ron Pressler from Loom, he is very opinionated on this topic. If you're ever in the Java subreddit, you might see him under Prawn 98. But first is that LTS is entirely a vendor concept. So right now, like the proposal was like initially was every 6 releases starting with JDK 11 would be an LTS release. Fundamentally though, Red Hat could be like every single release is an LTS release, or every 3rd release is an LTS release because they're our own vendor. But many the other vendors have also decided to follow that. So initially, Java 11 was going to be every 6 releases. So Java 11 was an LTS release, and then Java 17 is a LTS release. Just like Java 11 and Java 17. Okay, yeah. Then earlier, I think around September, Oracle proposed moving to every 4 releases to do an LTS release. So that would mean JDK 21 would be an LTS release for Oracle. I don't know if we adopted that officially yet, though I think that it's still kind of where we were heading as of this moment. Again, I'm a Brown, things may change in the future. So, but yeah, so it's every 4 releases. Again, that's up to the vendors though, as to whether or not they would want to follow that, though I'm guessing most would, but again, LTS is fundamentally a vendor concept. Any other questions or? All right, well, once again, thanks so much for coming out, and follow me on Twitter, send me a question, shoot me a DM. I'll try to answer as fast as possible, or reach out. I guess I know a few people in the OpenJDK area who can maybe also give a better answer as well. So, all right, well, thank you so much.
Thank you.